Okay, my beautiful pathway students, it's that time of year where we need to prepare you for algebra next year. You have gotten most of everything that 7th Accelerated has gotten. You've gotten the scientific notation and systems of equations and pretty much, standard fare on slope. And so a lot of those concepts need to be reviewed before next year, but it will come back to you. But the thing that we haven't touched on that you'll need to know how to do is prime factorization. And in order to do prime factorization, you need to understand how to find the greatest common factor and the least common multiple. Now that's a 6th grade standard, which you all probably were introduced to in 5th grade and have picked up along the way, if not, and we need to touch on it now because that is the key to prime factorization. So when you find the greatest common factor of two numbers, you're going to start with a number, let's say like 48, and we need to break it down into all its factors. So the first one we always start with is 1. Now I'm going to do this 2 different ways. I know there's pros and cons to both, so I'm going to write it over here and I'll show you what I mean. But 1, and of course itself, right? Those are both factors of 48. All right, what's another factor of 48? Well, 2. And it's 2 times 24. What's another one? 3. 3 goes into 48. How many times? 16, I think. All right, how about 4? Does 4 go into 48? Yes, it does. 12 times. And I don't know that I gave myself enough room. Does 5 go into 48? No. 48 is not divisible by 5. How about 6? Well, 6 times 8 is 48, right? Looks like I'm going to have just enough room. And what about 7? No, because 7 times 7 is 49. And then we're back to 8. So we have found all the factors that multiply to create 48. Okay? Now let's do that with another number. Let's take 52. 52 is good. So what are the factors of 52? Well, 1 and 52. 2 and what? I have to think about this. I could have made this easier on myself, right? 26. How about 3? I don't believe 3 does. How about 4? I believe 4 does. Gosh, I can't believe I can't do this in my head. I haven't slept well. 13. That makes sense. Because 26, right? All right, 5, no. 6, no. 7, no. 8, no. 9, no. 10, no. 11, no. 12, no. 13, we're back to 13, 4, and then 26 and 52. So those, oops, I didn't add it over here. Whoops, still have my eraser in my hand. So these, oops, not 3, 4. I'm really struggling. These are all the factors of, okay, these are all the factors of 52. What are all the common factors? The common factors. Well, 1, 2, Let me do this real quick. Put 52 out here. Put 48 out there. Just for grins and to make it more manageable. Alright, so 2 is common. 4 is common. Do they share 13? No. 26? No. 52? No. So the greatest of those common factors, the greatest common factor, the GCF, is 4. Okay? Now, people sometimes do it this way just because they like writing the factors out that way. You're writing them in factor pairs versus this way where you're trying to kind of squish them in and hope you've left yourself enough room or having these big gaps. But then you at least can see the greatest common factor or the common factors line up. Where here you'd kind of have to circle, 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 and scan the list. Either way, it doesn't work. You're just listing all the factors that make those numbers. And so I'm going to give you a couple example problems today for you to find the factors and find the greatest common factor, just to refresh the skill before we get into prime factorization. All right, good luck and let me know if you have any questions.